Varroa is a problem as beekeepers that we all deal with, but I can say this, I actually was able to keep bees before Varroa, and I think many of you in the audience may have been able to keep bees before Varroa as well. So I'm going to go through a little bit of a review of the biology. Then I'm going to talk about this Beltsville assay that we've been using it now, not for pyrethroids, but for amitraz, because amitraz is widely used in the US. And then I'll end with a story which I think is hopeful about bees that can survive without treatment, and that's the hope part. I think Willie Robson said that. Is that right? Willie Robson said, the only thing we have to fear is Varroa. If you're keeping bees now, Varroa is the number one thing that has changed in your beekeeping and the number one thing that you need to keep and be aware of. What I want to point out on this slide is that we've learned some new things about the biology. It doesn't affect us directly as beekeepers right now, but it could. And that is, on the brood, the female mite feeds and reproduces in the brood, and she feeds on hemolymph. So she's opening up a wound on the brood and feeding, her and her offspring are feeding on hemolymph. We've learned recently on adult bees, they're feeding on the underside of the thorax, the abdomen, and they're feeding on fat body. So the mite is, you see them here on the top of the thorax, but in reality, they normally are under the abdomen and they're feeding on the fat body. And that actually explains something that we knew about the biology, but we didn't know why they were doing it. And that is, it reproduces in the brood, but it feeds on brood and adult bees. So we knew from Varroa that they had to spend a certain amount of time on the adult bees, phoretic on the adult bees, but we didn't understand why. And they prefer nurse bees. So they're in the brood reproducing, the new daughters come out, they move on to worker bees, and they attach and feed on the fat body. And we believe that's now, in hindsight, is probably to activate their ovaries. They need to feed on the fat body of the bee. So we're learning more about the biology, and for most of us, we're only interested, well, how do we limit their impact? Yeah. If you don't treat, in most northern hemisphere, the mite will kill the colony in a couple of years. It builds up. I say this because in many parts of the world, in more tropical parts of the world, in Latin America and Africa, they don't treat at all. So this is a northern hemisphere or a temperate zone thing that Varroa tends to kill our bees in northern latitudes or in temperate zones. The one thing they do readily is transmit viruses. And I think the longer you have Varroa in an area, the more different viruses you have. Obviously there's interactions, and we know from some of the excellent work that DWV and some of these other viruses are probably the way that they're killing the bees. It's not the direct feeding, but it's more of the viruses. Just kind of a stylized graph of how the mites and the bees build up. So the bees come through the winter. The mites are at low levels generally in the early spring. And the bees build up on the red line. The mite buildup lags behind. But if you're monitoring your bees, you know that out here in July, August, and September, the mite levels untreated will start to go through the roof. They'll really go through this exponential growth phase. So this is kind of a stylized picture. And for us in treating, if we can keep them low in the spring, or if we can do a summer treatment before this explosion, where our bees are much better, we want to keep the Varroa levels down to produce good winter bees. That's the key, is the Varroa levels need to be down so that we get good winter bees. And I'll come back to this graph when I talk about these bees in France that I was studying. I've been studying for 2 years bees on this Ile de Gois in Brittany, France, that they don't treat, and I'll refer back to this diagram. I like the sugar roll test. That's how I look at my mite levels. About 300 bees in a jar with powdered sugar, count the number of mites that are fallen. And the other way is just sticky boards, simple sticky boards. Or sticky boards or some kind of screen bottom with a board. And then there's various action thresholds, probably 3 to 5 mites in a sugar roll or 30 mites in 24 hours on sticky boards. And that'll vary. I mean, it does vary. People I'm sure there's local recommendations for what is a treatment threshold. If you're going to control, what are you going to treat with? There's a lot of different products out there. Some of them have direct effects on bees. I'm thinking of some of the thymol products. I myself use formic acid and oxalic acid. I don't use any of the other hard chemicals. But whatever you use, you want to do some kind of rotation. You don't want to stay with the same compound over and over. It'll lead to resistance, and that's where I'm going with the talk. How to look for resistance in the mites if you've used a hard chemical over and over. If you use the same product, whether it's a fluvalinate or whether it's amitraz, if you use it over and over, you can lead to resistance, and I'll talk about now. Actually, before I get there, I'll talk about resistance mechanisms of the bees. I won't go in great detail about all these resistance mechanisms. Some of them you know fairly well. Hygienic behavior is a broad term that we use. It's bees cleaning out diseased brood, and chalk brood, American foul brood, things like that. So any diseased brood is hygienic behavior. The Varroa sensitive hygiene is a more focused type of hygienic behavior where they detect the Varroa under the cell and they clean out only those Varroa infested cells. And there's a lot of work trying to understand Varroa sensitive hygiene, or VSH. Recapping behavior, you're lucky enough, there's a workshop. Stephen Martin here in the audience is going to give a workshop later today or tomorrow. So I'd encourage you to go and participate in that. It's a fairly new behavior, or newly recognized behavior, where the worker bees, this is a cap cell, the worker bees come, they uncap it for a certain amount of time, and they simply recap it. And you think, well, that can't have much effect, but it does. The more recapping behavior they have, somehow it keeps the mite populations down. And I think the first publication, to my knowledge, was about 3 years ago on this recapping behavior. And then we have bees that can groom or bite the mites and damage them, so they literally can bite them and damage them. And also things like worker development time can come into play. About all these resistance mechanisms, we as scientists get focused on one. We start studying VSH, and we focus on VSH. I think in most of our bees, they're using multiple mechanisms. They're not relying on one. Two different kinds of hygienic behavior. One is more focused on brood diseases, chalk brood and stuff like. The other is focused on Varroa. But they're very similar. They uncap and remove the contents. And then this biting of mites. And certain bees, you can select for that. It is heritable. A group at Purdue University in the US has been doing a lot of work. But again, it's only one mechanism of many. Now we'll switch to the Beltsville test, as it's known here. In North America, I had a colleague, and she and I were developing these two assays, field assays, to detect fluvalinate resistance. And hers was very complicated. Mine was fairly simple. And we'd go to meetings, to get same meetings, she'd say, no, don't use my assay, use the Pettis test. So it became known as the Pettis test in North America. It wasn't a vanity thing that I named. I didn't name it that, she named it that. But it's a very simple assay, developed at Beltsville, Maryland. I got some funding from Project Apis-M, which is a funding agency in the US, to compare the Beltsville assay to a Veta Pharma assay. So you'll see better pictures of it in a minute. The Varroa wash, Easy Wash, I think it's called, the Varroa Easy Wash from the Veta Pharma sells, you can take that kit and change it up, kind of like a transformer. You can change the kit and turn it into a resistance assay, which is kind of nice. You use it to wash Varroa, right? I mean, to do Varroa. You can change it. And I was charged by Project Apis-M to test the Beltsville assay versus the Veta Pharma assay. And I'll just briefly show you some of that. So this is the two kits you take. Don't worry about how you do the easy check exactly right now. The key is that you have to keep that ventilated part off the bottom yellow cap. And in mine over there, you use a little spacer to keep it off the sticky board. So I'll show you another picture here in a minute. And the little yellow, or no, white material you see, that's amitraz or an apivar strip. And I'm using 3 times the amount of strip that we used in those other assays, which was, I think, in inches, 3/8 of an inch by the strip width. Now I'm using 3 times that amount for this assay. It's very similar to doing just a sugar shake. You collect 300 bees from a colony, you put them in the kit, you close the kit, they're exposed to the material. After 6 hours, you either invert mine and shake the mites out onto a sticky board, or in the case of the Veta-Pharma kit, the mites just simply fall into the yellow cup. And then you read those. A certain number of the mites have fallen or have been killed. Now you have to recover the mites that are left on the bees to get a percent mortality. So let's say you get 10 mites out, and yet there's 90 mites left. You would only kill 10%, so that's very low. If you kill less than 25%, 20 to 25% of the mites in this assay, you probably have resistance. It's not a resistance assay, it's just an indication. If you kill greater than 75% of the mites, you can control the mites with whatever the compound is, whether it's fluvalinate or whatever. So it's a general screening tool. It's not a definitive resistance assay. But as a beekeeper, it will give you some indication of whether that product will work or not. So again, if you kill less than 25%, you have a problem. And this is just a little better picture of, from the top, I'm using hairpins to secure the material so that the bees can walk around it on all sides. So I've got 300 bees in that jar, I've got 300 bees in the easy check, and the bees move around. It needs to be warm. It needs to be above 20, probably above 20 degrees C. The bees need to move in the assay. I hold them for 6 hours, and then I do the counts. And this is just a comparison. So we went through, and we got bees from the same hives in the 2 types of kits, and we were trying to determine the time it needed to stay in the kit and whether the 2 kits were equal or not. And here's just a picture of the mites falling into the yellow cap, real easy to count. The sticky board's also easy to count, but you need a spacer. You need some kind of spacer to keep the kit off the sticky board or off the bottom of the cap. And this is just a little bit of data. So this is the 2 kits compared at 2 hours, 4 hours, and 6 hours, and the percent mortality. And I went and worked with Randy Oliver for this because he had mites that had not seen Amitraz in 10 years. So I think that first picture you saw, it was Randy Oliver in there. He and I worked together because he said, you know, hey, I've got susceptible mites. You need a baseline. And this is susceptible mites at 2, 4, and 6 hours. And by 6 hours, we were killing about 90% of the mites. So we don't want to run it any longer because we've already got an indication. And if at 6 hours, the mites are resistant, you're going to kill much fewer. So we recommend running at 6 hours. There's a publication out of the US that recommends they run their assay only 3 hours. I think that's a little short. I like to run the field assay 6 hours. So just a bit of information. So we went out and tested it in the western US with 8 commercial operations, and they came from different states within the US. And we did find evidence of resistance in 2 of the 8 operations. It wasn't in every colony we tested, and it wasn't in 6 out of the 8 commercial operations. It's out there, but there's a very unusual thing about Amitraz resistance, and that is we had evidence of it 10 or 15 years ago. We had some publications that said Amitraz resistance was out there. When we got fluvalinate and coumaphos resistance, it came very quickly. It came in 2 to 3 years, and it was widespread. For some reason, Amitraz resistance has been very slow to accumulate, and it doesn't seem to fix in the population. There's something about Amitraz resistance that doesn't, something genetic in the mites or the cost to the mites. It doesn't fix in the population as readily. And we don't understand that at the moment. But there is some Amitraz resistance out there, and this assay will at least give you some idea of whether your mites can be controlled. My objective, Project APSM, said, are these 2 kits comparable? And yes, they were. So either one of them worked equally well. And that's a pretty good picture of the easy check inverted. And the only difference, so you got the bees in this upper part, the material is in the ventilated part with a hair clip, and then in the bottom of that yellow cap is a little spacer. That's how you run that assay. And you know how to run the Beltsville assay. Now I'm shifting gears because I don't use hard chemicals at all in my own operation. I thought I'd just give you a flavor of what I do or what my family does with the bees that we keep. So we manage between 75 to 125 colonies, about 2 hours outside of Washington, D.C., and I do some pollination, and that's why I keep bees on these trailers. So about 12 to 16 bees on a trailer. It's very easy to move from field to field to pollinate. I run singles all through the year. Occasionally in the spring, I'll have to double up colonies if they get too big. My primary swarm control is simply making nukes. If the colonies are too strong, I try to make nukes, and I get some swarming. But for the Varroa management, I use slow-release Formic Pro from Canada. I use it in the summer. I use that in the summer, and I use oxalic in the winter, and that's it. So I do monitor my mites a bit, but mostly I just do those two things, and I've been fairly successful with that kind of, without any hard chemicals. The other thing, when I have time, I look and try to graft and do a little queen rearing from my best colonies for local selection. And this is my son, Kevin, who helps with the operation. And since we're at the honey show, occasionally we produce some really nice comb honey, but not very often. And this is me moving bees in the rain. And my wife was with me, Marianne, and she helps with the operation. We sell at 2 local farmers markets. And we were discussing last night with some of the honey judges. We sell out every year. We sell all the honey we can produce. And yet I have a high school nearby that they have 4 or 5 hives, and they sell honey year round. And so I get people coming up, oh, I support the high school. I buy their honey because it's local honey. I'm like, I just don't say much, but how could they sell honey year round from 4 hives? You know, but anyway, it gets into one of the best ways, and that's a different talk, but one of the best ways to work on honey fraud is to educate your local consumer. That local honey, you're producing it, you know, that kind of thing. And that's what we do. We sell out by October, November. We sold out before we came over here. So I'm switching gears now again. I want to give a new twist on Varroa, something new that we learned about Varroa. This is Apis cerana. It's the original host of Varroa. And Varroa came because humans move them around. They moved off of Apis cerana onto Apis mellifera. When we were talking about resistance mechanisms, we thought if we could figure out why Apis cerana is not affected by Varroa, we'd have it solved. So Apis cerana does something. Varroa only reproduces in the drone brood in Apis cerana, Asian honeybee. If we could figure out how that is, we'd solve Varroa problems because we could use that in our bees. Well, about 2 to 3 years ago now, there's a paper published. They went to China and they introduced Varroa directly into the worker brood of the Asian honeybee. So it normally doesn't go into the worker brood. They put it into the worker brood of the Asian honeybee, and they left it in there for a certain amount of time, and they uncapped. The worker brood died. So it was, I think they called it, now I've forgotten the term, something suicide or something. Yeah, it's the bee itself, as soon as the Varroa feeds on the developing brood in the worker brood, the brood dies, and there goes the Varroa. So it's huge selective pressure to only reproduce in the drone brood. The problem is our bees don't have that. So our worker brood tolerates Varroa somehow. And so, yeah, the same mechanism doesn't work in our bees. But the original host, it does have a fairly strong mechanism to keep the Varroa only in the drone brood. So it's another new advance in our knowledge, but it doesn't help us much. So now I'll switch and I'll end. This is the part about the hope part to me, that if bees are bees and mites are allowed time, they will come to some kind of equilibrium if we're not constantly treating. And I'm not saying that we can do this in all circumstances. This is an island off the coast of Brittany in France. It's right near Belle-Île. Some of you may know Belle-Île, but this is Ile de Groix. And I was hired to do some consulting work on there. They knew that they were fairly pure Apis mellifera. They were dark bees on the island. And the beekeepers there claimed to not treat. They said, oh, we don't treat, we don't feed, and yet the bees are living. So Colonies, this NGO in Paris, said, we'd like to document that. So I worked there for 2 years and tried to understand, were the bees really living, coexisting with Varroa? And so we monitored both wild colonies and managed colonies, and I worked with 6 different beekeepers on the island. And then at the end of this, we began to explore possible resistance mechanisms. I'll have a little bit to say about that. So this is the 3 partners. Polonies is an NGO in Paris, and Nicholas Larman is the fellow there in the blue shirt. Christian Bargan is the main beekeeper. He runs an association on the island, and I'm pictured there. The Asan GX is the Association for the Preservation of the Dark Bee there. And I know there's other groups around Europe that are also preserving dark bees. We were particularly interested in survival of the wild colonies on the island and the managed colonies, and documenting that the beekeepers weren't treating. So as a scientist, the very first thing I'm like, well, no, they're probably treating. They're just not telling everybody that they're treating. So how would I find out if, in fact, they were treating or not? Test the wax, exactly. You see the wax in the pig. They have a lot of wax where they have the bees draw it out. So I tested wax in all 6 operations, and it came back extremely clean. There was a few ag chemicals, and there was a little bit of evidence of amitraz, but that could have come from Foundation or wherever. I mean, it was super low compared to wax here or compared to wax in North America. It was super low. So I was convinced they weren't treating. That was the first thing. So they're not treating. Now we have to look at the mite levels. And again, so we manage in many different ways. The bees are managed commercially or for hobby. But this Asan GX, all the people in the group, they kind of just believe in live and let die for the bees. They don't. The key for me is that I don't do a lot of mite treatment, but if my bees need feeding, I'll feed them. And they don't even feed. They just let the cycle go. And again, most of us, use some form of treatment for Varroa. Yeah. So we're going to monitor Varroa over 2 years in the spring and the fall, because I'm expecting, to see some kind of pattern in the mite levels. And I use the sugar shake method. And this, I'm referring back to this figure, because in the spring, I'm expecting the mites to be at some level. Go back in the fall, the same colony, I expect without treatment that the mites will go up. And here's just one data slide. So each cluster of bars is an apiary, and so it's spring of the first year, fall orange is the next year, and then spring is gray, and fall is that golden color. You see that in certain cases, the fall does go up, but it really wasn't dramatic. It wasn't as dramatic as I expected, because in my own bees, the difference between spring and fall before treatment can be 10 or 15-fold, 20-fold. So in this case, if you look at apiary 4 or apiary 5, they literally were constant. They were, in my mind, they were constant. There won't be any significant difference between the spring and the fall population. And this is all without treatment. So now we got to ask, is it the bees or is it the mites? And so we started to look at resistance mechanisms within the bees. And this is just reinforcing that fall in northern hemispheres, the mite levels should go up. So we started to look at some of the behaviors. We tested for general hygienic behavior, but we only were able to test once. So it's nice to test once and then follow it up with a second test and know if they're truly hygienic. But even with one test, we got an indication that about 50% of the colonies were hygienic. but the other ones were not very hygienic. We did a little bit of VSH testing, but not enough to really lock in on that. It's just more intensive. We did look at recapping behavior, and we looked at recapping behavior fairly intensively, and there it was about 30%. About 30% of the colony showed a fairly high level of recapping behavior. And then the other thing we looked at was with sticky boards, we looked at this biting behavior or damage behavior. And there again, it was ranged between 30 and 50% of the colonies had this high mite damage level. So what are they using to fight the mites? I think they're using a little bit of everything. We also don't know if the mites have adapted somewhat and are less virulent or their reproduction is lower. We don't know much about the mite side of the equation. But in general, for me, the take-home message of this is that they're probably using multiple resistance mechanisms. The other thing that's a bit interesting is we found no American foul brood on the island. So if you follow the news, this is Ile de Goix, and on the point of Brittany, there was an island called Ouessant, which is, and they had no Varroa for a long time. And recently, in the last 2 or 3 years, they've gotten American foul brood and they've gotten Varroa. So these mite-free bees out there, they were using the beeswax in cosmetics, that market has gone away. But on Ile de Goix, I was surprised to not find any American foul brood. There is the frilon, the hornet, that's spread through France. I guess it's in southern parts of England now. It's across the channel. This is not that same frilon. It's just a picture I had. But they're fairly strong predators out there on the island. They do cause damage on the island. And now just a little bit about the island itself and how the colonies are arranged and things. The island is only about 3 kilometers wide by 8 kilometers long, so it's not a very big island. And I only worked in 6 of the apiaries on there. Those numbers, starting at 2010, going up to 2018, are the number of wild colonies that the association had found. And it starts out low because they hadn't found them all. And then it starts to equilibrate about 30 wild colonies on the island through about 2018. And then further and further, it got up to 50 wild colonies on the island. So they've been monitoring that. And the survival, we look in the fall at the colony, the wild colonies, and we look at it in spring before swarming. So we know that it made it through the winter. So we can look a little bit at wild colony survival. And it's fairly high. The wild colonies, obviously they're not treated, and they're surviving quite well as well. But there is a problem on Ile de Goix. There's a problem with beekeeping is becoming too popular, right? I mean, there's so many people that want to keep bees that in certain cities, in certain areas, people are like, well, we're overstripping the resource. So this is from 2008 on Ile de Goix. There were 7 abandoned apiaries that people weren't managing and 9 locations where people were managing hives. And they probably had about 150 hives or something on the island at that point. I don't know the exact number. But look, this is 2008. Go forward into 2022. And now there are 24 apiaries, from 8 to 24 apiaries. On the island, it's becoming very popular. And they're worried. They'd like to see some system where you have to register and only a certain number of bees can be kept, because I think they are overstripping the resources on the island a bit. And maybe we'll see that in these wild colonies. If they're overstripping, the wild colonies may not do as well. But in any case, there is a problem of overpopulation of managed colonies on the island. A little bit about where they nest. There's not so many trees on the island. This is actually a tree in North America, a little sleight of hand. But there are some trees where they nest. They nest mostly in rock, in some old rock walls and rock forts. And I'll show you a few pictures of those. This is a fort along the coast of the island, and that little dark cavity kind of in the middle, I guess the right-hand side, is that colony has lived for about 8 or 10 years. So there are some long-lived colonies, wild colonies on the island. The average lifespan is probably about 2.5 years for the wild colonies. They live, they die out, but they're always swarming, so a new colony forms. This is the lighthouse on the north end called Pin Men, and that colony as well in the chimney. The little inset is a chimney with the lighthouse keeper's house, and that colony survived over 6 years. So there are colonies that persist for long times. This is just a typical house. We find most of the wild colonies in a house or in a chimney. That's the most common place. And here's a picture right in the center. The bees are kind of going under that, into a wall, perhaps in this case, not a chimney. And this is just a case of a tree. There are a few trees. And in this case, the tree was big enough and there was enough cavity. If you can see on that bottom inset, you can get a good feel for the color of the bees. The bees are a very dark Apis mellifera. And they were tested in 2016 by Lionel Garneret and known to be pure. We tested them again recently, and they're very pure mellifera. And this was just an interesting case where this is right near the coast, right on the water, and the rock you see there is a dolmen. It's a rock that had some supports under it. Well, we found the bees nesting under the rock underground, and there you see the bees flying under the dolmen. They only survived one winter. So we found them there in the summer. We looked at them in the fall. We found them the next spring. They didn't survive the second winter, but they nest wherever they can find a cavity. And of course, they nest near the boulangerie, every town has a boulangerie. And this is just a distribution of the wild colony. So the circles, the yellow circles are where I was working, the 6 apiaries spread out across the island. And all the little X's are the wild colonies. And what you probably can see is that there's little clusters of X's. And that's because that's the cluster of little communities where the little houses were. So they're all over the island, but they tend to nest with humans because of the type of island that it is. Thinking about bees and Apis mellifera, we keep Apis mellifera, whatever, ligustica or buckfast, whatever, but it's the same species that we manage from really cold climates all the way down into the tropics. So there's a lot of adaptation. Then we have subspecies like mellifera. But if you think about it, to have one species that's spread across the globe is pretty amazing. And again, in tropical areas, in many parts of the tropics, they don't treat for Varroa. So there's something else going on there that resistance, there's other mechanisms that they're using for resistance in the tropics, in Africa, South America. And so I have to ask, when we're selecting our bees, and I'm not saying I like a nice gentle bee, we select against stinging, we select against swarming, because we don't want them to swarm and lose our honey production, and we select for high honey production. But if you think about it, that's not exactly what the bees need to survive. The bees need to swarm. They need to swarm to reproduce. Now, if we're beekeepers, we can do that. We can manage and suppress swarming and keep the bees alive. But in nature, bees naturally would swarm. They naturally would have some stinging behavior. And of course, they do need honey production. They need some honey production. But so I have to kind of ask the question, if we were selecting on survival, and I think that's what was happening on Ile de Groix, the selection has been just towards survival, a bee that will survive. It doesn't, they're not terribly aggressive. They're not huge colonies. I always get this, how big are the colonies? They're about 8, they average about 8 frames of bees. And they do produce some honey. Not a lot, but enough. And they produce enough to get through the winter. So in our selection process, we're suppressing stinging behavior, which is good for us beekeepers. We're also suppressing swarming, which is against survival of wild colonies. So on Groix, I think natural selection has taken over because the beekeepers aren't treating. And it gives me hope that even with our scientific selections, if we work towards a Varroa-tolerant bee, that with some of the management techniques, we can get there. So we're not constantly fighting Varroa with chemicals and harsh treatments. So I think we can get there. And I guess for me, I select from my own best colonies, and you can do the same. Just you'll have bees in your area that do best, and selecting from local stock is a good way to go. And that's the harbor at Groix. if you get a chance to go out there and visit, it's a beautiful little island. And I thank the beekeepers of Blois. This is Christian Bargan and his wife Marcel, and the beekeepers are very cooperative. And I'd like to close and put my Apimondia hat back on and invite you to Chile in 2023. We just finished in Istanbul, Turkey. But if you can't make Chile, and you just can't afford the airfare or whatever, then come to Copenhagen, Denmark in 2025, and we'll discuss more beekeeping. So thank you.
In these colonies which haven't been treated, did you notice a reduction in viruses such as deformed wing viruses or sac brood or anything like that, as well as no AFB?
Okay. So a good question about what was the virus situation in the colonies and what did I notice? I rarely saw symptoms of deformed wing virus on the bees. I saw it occasionally. We did one sampling for viruses, and that work was done by Dave Tarpe at NC State, and we haven't published that yet, but we found 3 of the types of DWV. We found black queen cell virus. We found most of the common viruses, but not everyone. And because we didn't sample over time, I can't say much about what the viruses were doing. But they are present. We know they're present. But I don't know the exact interaction with the viruses. The brood in general, I didn't see, I saw occasional chalk brood, very occasional chalk brood, but no AFB. Yeah. And on the bees themselves, I saw very, very occasionally did I see deformed wing virus symptoms, a twisted wing.
You said that you treat twice using Formic Pro and then trickle method.
Right.
The climate that we've got at the moment, so last winter I sublimated once, and I had a serious Varroa issue this year. If you're using the trickle method, my understanding is the recommendation is you only recommend trickle once, you don't do as you would with sublimation 3 treatments. And now our autumn is unbelievably warm. Would you switch to sublimation and do it 3 times in winter, or would you still just trickle once and hope that the Formic Pro is sufficient in summer?
A good question. I'll tell you why I use the trickle method. It's because I'm lazy. The sublimation method works better, I think, in general. But for me, I'm not trying to kill all the mites, so I'm okay with the level of control I'm getting. I would say the sublimation method is usually you get a higher efficacy. And yes, this autumn is crazy. I was expecting, coming here, I was, expecting winter, and it's been warm. So mite levels in the fall are probably going to be elevated. There's much more brood rearing, so switching to sublimation multiple times would probably be a great idea. Yep.
I noted that you said on the island they only practice very natural beekeeping, so I assume they let the bees build their own comb?
Yeah, they might put in starter strips, but they don't provide foundation.
Yeah.
Right.
So could that be a factor in that the drone brood would be probably produced in one place by the bees rather than, as a lot of us use foundation, which is worker foundation, and the bees have to produce drone brood where they can.
Right.
So could that be a factor as well in the low Varroa populations, in that it's kind of together in one place and the bees can manage it in the drone brood?
It could be. I mean, I saw in my experience, when you have natural comb, they're going to just build a little bit of drone comb here and there where they want it or need it, and it doesn't always end up in one place. But yeah, they will certainly only build enough drone comb that they need. But I don't know about as far as affecting the way then the Varroa was controlled or not. I can't say. Okay. Now, if you were trying to do harvesting, I've used a Langstroth hive, or no, a medium depth, and they'll build drone comb right below that, and you go in when it's all capped and you just cut it off and remove it. So that's a really simple way. If you're doing drone brood removal as a control method, you put in a medium comb in a deep frame spot. What they build down here below is almost exclusively drone comb, and you just monitor it. Come back when it's mostly capped, cut it off, and you've eliminated a lot of Varroa.
Yeah, thank you.
I just want to check something actually. Am I right in thinking that Varroa mites don't develop resistance to formic acid or oxalic acid? And I also, as a supplementary, I also wanted to ask, do the beekeepers on Ile de Goix not do any swarm management with their bees if they're natural beekeepers?
No. So the answer to the first question about can mites develop resistance to formic or oxalic acid? It's our understanding that they can't, but you never say never. We've been using formic acid for a long time in Europe and North America. And I think because of the mode of action of formic and oxalic that it would be difficult for them to develop resistance. I don't say it couldn't happen, but yeah, as I understand it, it wouldn't happen. For the second question, they don't really do swarm control. They will occasionally make a nuke if a colony is getting really big. When they see swarm cells, they'll take the swarm cells and a few frames and make a nuke. But then they don't cut swarm cells. They just remove some to make a nuke to get another colony going, and then that colony still could swarm. So they don't do really active swarm control other than making an occasional nuke.
You mentioned the research that they did on Apis cerana, which is where you think the Varroa came from originally.
Right.
And if I've got it right, they introduced it to the brood, the worker brood, and that worker brood just died.
Right.
So could you just expand a little bit more on what is happening in China? Because obviously that's where it came from. If that happened and continued to happen with Varroa in the quantities we've got it here, then you'd expect phenomenal colony collapse. But by the sound of it, you're not getting that. So could you expand on that research?
Well, so in China, because as you probably know, China is a major honey exporter, or honey in quotations exporter. They have a lot of Apis mellifera there. So they brought in Apis mellifera because they believe it's more, it produces more honey. I think your question was, if the Varroa is moving into Apis cerana and the brood is dying, that would be detrimental for the colony. It happens, very few Varroa in China would make that mistake because they'll die. And so it does happen, but it happens rarely. And so I don't think there's any effect of the Varroa killing the brood in Apis cerana. And that's only in Apis cerana. In their Apis mellifera colonies, they're having to manage Varroa. In China, they're having to manage Varroa. But it doesn't get to the level, because it's kind of a dead-end street, once a Varroa goes into a worker brood cell of the Asian honeybee, it dies. It doesn't happen that often. It has happened over time, and that's why we only see them in drone brood.
It puzzled me why Apis cerana is drone only, because presumably the drones are not there all the year round as they are in workers. So there must be almost a brood break then from the Varroa's point of view.
Yeah, there could be, because if there's only drones in the colony that's true. If there's only drones in the spring and early summer, and as you get into fall, there's no drone brood, then the Varroa levels would be less. You bring up a very good point, because not only does it not infest worker brood, in general, people who manage Apis cerana, you wouldn't do anything to control Varroa. Varroa is just not a issue. So it's probably twofold: this brood break that you mentioned, and the fact that it's restricted to drones, and we only need so many drones, right? So, yeah. So you're probably right. There's as we go into late summer and fall, if there's no drones, and they're reluctant to go into worker brood, then you'd get a natural slowdown in the reproduction of Varroa in Asian honeybees. Yep.
You mentioned the Asian hornet on the
Okay. Yeah.
Can you tell us what measures they're taking against the Asian hornet there, please?
Sure. They're doing. It starts with badminton. Do you know what I mean? It starts. No, on the local level. A beekeeper, he or she, can go out with a badminton racket, literally, and just swat some. Most people are using some form of trap with a bait inside and a funnel, so that the hornets kind of fly into the box, and through a funnel that gets smaller and smaller, they get in there and then they can't find their way back out. And yet the bees can't. If the bees go in there, they can fly out because the bees are smaller. So we were just in Brittany at this bee calm meeting, and there must have been 5 different kinds of hornet traps that people were selling. Most of them involved a bait. Very simply, you can stand out in front of your colony if you have time and just knock them down. But it's a feel-good exercise. You're knocking them down. Where there's a lot of research going on is locating the nest, locating the early nest, the small foundress females that come through in the spring, reducing those. But the bigger problem is when they build the big nest into this late summer. If you can find those and destroy them before they produce reproductives. So most wasps and things like this, they go through the summer, they build up, now they have a big nest this size, and at some point they start to produce queens and males for the next year. And if you can take that nest out before it produces reproductives for the next year, you can help lower the population. So there's all kinds of gadgets. There's drones with heat cameras that they're using to try to locate them. There's a lot of different work going on locating those nests and killing them. So there's some other ways that people are trying to get at that hornet. But it can be a problem in the late fall with consuming a lot of bees and damaging weak colonies. So.
You noted that the treatment with formic acid and oxalic does not incur resistance, but are we nevertheless breeding a stronger Varroa rather than a stronger bee, and that by not treating, we reverse that situation?
Well, that's, there's a big dynamic, and I hear it from different sides. So I'll try to explain it simply. Here's the completely no treatment people over here, and here's the ones we got to treat Varroa because if not, our colonies totally collapse. There's room for both types of beekeeping, but certainly if you let things go and let the Varroa have pressure on the bees, and you'll get to some kind of equilibrium. That's what Ile de Gois shows. But we can't all do that. So we can accommodate both kinds of beekeeping. But you're right, even with formic and oxalic, you're killing off mites and you're not letting Varroa put pressure on the bees to get natural selection. But it's this ongoing battle. I treat because I need to meet my pollination needs, and I can't afford huge losses. If you take the Gotland example, most of you might know Ingemar Friis did an experiment. He put 200 hives on an island in Sweden. I think it went down to 40 the first winter, and then it went even lower the second winter. And so they came down to just a few surviving colonies. And then they slowly built back with Varroa, and they kind of survived. But in fact, they weren't very good. They weren't very good bees. They were very small colonies, but they would survive without treatment. The ones on Ile de Gois are real bees. They're real colonies. They'll produce some honey, but it's a trade-off. We have to have productive colonies in agriculture. For pollination, we have to have productive colonies. So there's room for both, I think. Yep.
How does your research, do you feel, tie in with the work that Tom Seeley done in the Arnott Forest, where again he sort of showed it went down to, I think it was 2% and then back up again, and they are surviving quite strongly there in the wild colonies, unlike the other one you just mentioned. Where it sort of says that there will be a percentage of bees that become Varroa resistant, just like Darwinian traits in terms of evolving basically. And I just wondered how your research on that island seemed to align to that. Then they're not treating again smaller colonies. He was talking about Arnott Forest, the smaller colonies, the swarming, and all of this being part of the process. I just wondered how the two bits of research aligned or didn't, maybe.
No, it's the same kind of thing I think the difference there is in the Arnott Forest, there were just these natural cavities, and the bees slowly built back in the cavities within that big forest. And on Ile de Gois, you've got managed hives and wild hives, and to me, they're one population. So, but there is beekeeping activity, but you're right, it's the pressure, letting Varroa put pressure on the bees and come to some equilibrium. I think they're identical. The situations are identical, except on Ile de Gois, there were managed bees, and there's a chance that it slightly changes the dynamic a bit, but they're very similar.
First of all, a shout for Bee Base, which is a wonderful resort which we have here, which is run by our National Bee Unit. So you can do a Google, put in a sum, say how long you've treated your bees for, how long you've been measuring your Varroa drop for, which is usually a week, what kind of hive and what kind of reason, what kind of season it is, and it comes back with a sum that says, oh my goodness, treat now. The answer I'm usually looking for, which is treat in 9 months' time, which means I can shook swarm.
Right.
So for 6 years, I have treated, I run 14 colonies, and I've treated 4 colonies, different colonies, over that 6 years, because I haven't managed to fit in the shook swarm at the right time, and that's usually been weather-related. And it's usually my biggest colonies that get Varroa, and I assume it's because they're robbing. Which leads me on to my other question, which is how are you defining wild bees? Because when I was looking at your map, I was kind of defining wild bees as escaped swarms, or are they different?
So I'll answer the first part. The free living bees, maybe wild is not the right term. They're free living. They're living in some cavity that humans aren't adapting. Almost all the bees that I know of in different areas at some point escape from managed hives. I've been doing some work in another park, and you have managed hives in the valley, and up in the mountains you have bees living in cavities, but they originated from managed hives. So free living is a better, maybe a better term for that. All Varroa management is local. I mean, it's going to change seasonally. If you're monitoring, that's a great tool because you want to know, like, can I get through to the fall or can I get through to the next spring? Yeah. So anyway, I mean, that's important to know what you get a sugar shake to know what that means and locally in your environment. So, and yeah, if you've only had to, and back to the large colonies, it could be 2 things. One is the large colony has more brood, so there's more Varroa. But you're right, it could be robbing and bringing out the mites. Yeah.
A few years ago, there was a lot of discussion about whether Varroa itself was a problem or whether the problem lay with the virulence of different strains of deformed wing virus. I've not heard much about that recently, but to me it seems a very significant issue. Have you got any comments on that, please?
There are more virulent strains of specific viruses. So yes, certain viruses are more virulent than others, and it changes over time. There's another thing that the Varroa itself, their reproductive rate and stuff can vary. So, like on Ile de Gois, it could be that the Varroa themselves have adapted a bit. Maybe not the viruses, but the Varroa themselves. So there's multiple things going on with this host-parasite relationship. But certainly with the viruses, we do know there's a lot of work on the virulence of the virus itself, and it does change quite a bit. So you could have a situation where in your part of the country, those viruses aren't as virulent, and the mites and the bees are kind of going along okay. You have you could tolerate higher mites, whereas in another part, with a virulent virus, you really need to keep the Varroa much lower. Yeah.